Hi. Now I'm assuming that if you're watching this particular video that you are on my website and you've watched the previous one to this, and that was where we tried to use the factor theorem to factorize a cubic polynomial, this one here, 2x cubed minus 3x squared minus 11x plus 6. And what I showed you was that if we defined it as f of x and we tried various values of x. I chose x is 1, substituted in, we got minus 6. We're looking for a value of x that gives us 0, and we tried several other ones. F of minus 1 gave 12, f of 2 gave minus 12, but eventually we came across f of minus 2, which gave us 0. And by the factor theorem up here, it led us to the conclusion that x plus 2 was a factor. And I showed you that if f of x was identical then to x plus 2 times another factor, this factor could be found by dividing f of x by x plus 2, and we did it here. And it's at this point that I said to you that there was also another way that we could get this quadratic factor. So that is the purpose of this tutorial, to show you the alternative way. So what we'll do is we'll just remove this version here and I'll talk you through the next version. Now what we have is then that f of x is identical to our linear factor x plus 2, which we've already discovered down here, and then we've got multiplied by another factor which is going to be a quadratic factor, something of the form ax squared plus bx plus c. Alright, now we've got to work out what a, b and c are. But it's not that difficult, because when we multiply this out, we're going to obviously multiply x with each of these three terms here and then follow it with 2 times each of these three terms. Now when it comes to the x cubed term, in this case 2x cubed, you're only going to get an x cubed term once from doing x times this term. X times the bx would give an x squared term, x times the c would give a x term, and so on. 2 times this ax squared will give an x squared term, 2 times the bx gives an x term, and 2 times the c gives a constant on the end. So the only x cubed term comes from x times ax squared. And that's got to be 2x cubed, so what must the a be? Well, it's got to clearly be a 2. So we could write a 2 in there. X times 2x squared, 2x cubed. Now the other easy value to establish is the constant c on the end, because the only way you're going to get a constant is by multiplying this number, plus 2, by the constant on the end here. So clearly, what do you multiply plus 2 by to get plus 6? Well, it's got to be plus 3. So the c there is going to be a 3. All it leaves us now to work out is the b value, the coefficient of x, as we say. And there's several ways that spring to mind that we could do this. We could compare maybe the x squared terms. Let's show you. If we were to compare the x squared terms, what are we going to have? Well, if we were to multiply this out looking for x squared terms, we're going to get one when we do x times bx. So we'd have bx squared. So there's going to be a bx squared. When we do x times the 3, well, that's going to be an x term, so we don't want that. Now when we do the 2 times the 2x squared here is going to give 4x squared. So that's an x squared term, so we're going to have plus 4x squared. But that's the only other x squared term, because 2 times bx would be an x term and 2 times the 3 would be a constant. So what do we know that this is going to be identical to? Well, we're looking for it to be identical to minus 3x squared. So minus 3x squared. So if we ignore the x squareds here, we can see that therefore b plus 4 must be identical, or in this case it's got to come to minus 3. So to work out what b is, just subtract 4 from both sides, and therefore we have that b equals minus 3 minus another 4, which is minus 7. and you can see that then that would be minus 7x. We didn't have to compare the x squared terms though. We could have compared the x terms, and I'll run you through that one. Okay, if we were to compare the x terms, how would that have fallen out? Well, we've got, when we multiply the x throughout here, the only x term we're going to get will be when we do x times the 3. So it'd have 3x. And then don't forget we've got to do the 2 multiplied by the bx here. 2 times bx will give us an x term, 2bx. So that'd be plus 2bx. And what's that got to be identical to? Well, we hope that it will come to this x term here, minus 11x. So if we ignore the x's now, it therefore means that the 3 plus 2b must be equal to minus 11. And if we subtract 3 from both sides, we've got 2b equals minus 11 minus 3, which is minus 14. And if we divide both sides by 2, we end up with b equaling minus 7. Obviously it's got to be the same value as we established here, and you can see it works. Okay, so now that I found out what b is, I could substitute it back into here. Well, I'm clearly running out of room here, so what I'm going to do is remove this and we'll just carry on as I did earlier. So once you've got that b is minus 7, okay, we can just fill it in. So we'll remove this, and so we now have that therefore f of x is identical to x plus 2 multiplied by 2x squared minus the 7x plus 3. And as we did earlier, we factorise this quadratic factor. Sometimes the quadratic factor won't factorise again, but in this case it did, to two linear factors. One was 2x, the other was x, and we had a minus 1 here and a minus 3 there. Alright, so we've got f of x factorised now, and we did it by this particular method, avoiding algebraic long division. But leave it up to you. You decide which method you want to use.